All right, let's move on. So in this module, we're going to focus on understanding JavaScript in the browser. So this is the browser, our Chrome browser, or Firefox, or Safari. How will JavaScript interact with this browser? Okay, and then we'll be able to explain the role of web APIs, use basic DOM, document object model APIs, describe ways Lightning components abstract the DOM. In this exact video, we're going to focus on these two. So how JavaScript works in the browser. So in this module, we focus on the relationship between JavaScript and the browser, with a special focus on how your web page looks in JavaScript. Right. So the JavaScript runtime is not the browser. Okay, the JavaScript runtime is not the browser, nor is the browser JavaScript. So let's get into this. So the JavaScript runtime engine, the engine that interprets your JavaScript code and renders it and display the result or act on the code, runs in different many places. The JavaScript runtime engine, the engine, right, runs in different many places, but it's most often hosted in a browser like Google Chrome, Firefox, Safari, Microsoft Edge. So those browsers have the JavaScript engine in it, okay? But the JavaScript engine is not the browser, and the browser is not the JavaScript engine. You get it, right? So the engine is inside the browser. So what's the difference between the JavaScript and the browser? I just told you, all right? So a browser's primary job is to act as a client for a web server, to render and display what is being served, like a server is serving stuff, right, by the web server. So the web server spits out a bunch of code like this. This is the code that spits out by the Trailhead here, our Trailhead server, web server. It spits this out, a bunch of JavaScript. See, script. This is all JavaScript, JS. So this is spit out from the Salesforce Trailhead web server. The browser reads this like a robot, and then it interprets it and display based on this code what to do with that, right? So this browser has an engine that knows how to interpret the JavaScript part and also knows how to display or render whatever HTML, CSS code that's also in the source code from the web server. So it requires resources over the internet, okay, using one of several protocols, usually HTTP, Hypertext Transfer Protocol, or HTTPS is encrypted, Hypertext Transfer Protocol secured, so it's encrypted, so there is no hacker can hack your code in between. So once a server passes it some of those resources, the browser needs to do something with them. At a minimum, HTML and CSS are rendered into a page, right? So I just showed you the source code, and this is the result, what you're seeing here, right? This is an image resources and all this hover. This is all JavaScript, okay? So those are the resources, and then this browser interprets it and display this whole thing. Okay, where were we? So, okay. At a minimum, HTML and CSS are rendered into a page. When a resource contains some JavaScript, the browser reaches over to the JavaScript runtime engine. Okay, like what do we do with this piece of code? I'm just gonna view source again. Where's my view source? View source. So it reads this is HTML. Oh, I had blah blah blah. Oh, this is a script. Oh, this is JavaScript, right? So what do we do with this stuff, Mr. Browser? Oh, I know, Mr. JavaScript engine knows what to do with this. Let's ask them. So the JavaScript engine interprets this, or all these scripts. If I click on it, you will see the source. This is all JavaScript, right? Or referring to the JavaScript, we have a bunch of JavaScript here. Like this is the CSS, and then what else? This is all JavaScript. So whenever the source has JavaScript stuff here, it will give to the JavaScript engine to interpret what do we do with this piece of code, and then the engine calculates it and then do what it's supposed to do. All right. So the browser reaches over to the JavaScript runtime engine to parse the code, evaluate, and then what? Execute the code if there is no error. All right. We've talked about this on the previous module. We're gonna review that a bit. So to make these interactions work, the browser brings surfaces. A bit confusing for me at first. What is the author of this module keep using the word surfaces? Maybe to make it fancy smancy, you know, but it basically means bring. To make interactions work, the browsers bring APIs, brought to you APIs, okay? So in fact, a large part of what people think of as client-side JavaScript is actually these APIs. So let's move on. Web APIs. What does API stand for? Application Programming Interface. So application programming interface, for us to be able to talk with other platforms, we use APIs. So for example, this browser wants to talk to we're going to talk about this, right? So okay, where it is. Let's read this. It should be surprising that there are APIs to interact with the browser. Just like any other programming language or platform, Surface uses APIs to interact with the environment it runs on, so too does your browser. So while over half browser internet traffic comes from Google Chrome, like I'm using Chrome right now, roughly other 30% comes from 5 other browsers. So there are not just one browser, there are other browsers. People use Firefox, people use Safari, people use Microsoft Edge, I don't think Opera exists anymore. Opera, Netscape, that's my olden days, you know. I don't know, some other stuff. This underscores the importance of the web standards for these APIs. What does that mean? That means we have to have a standard, right? So we want this exact code, whatever we have here, to display exactly the same in Firefox, in Chrome, in Safari, in any other browser. It should exactly display like this. If we have no standard, Firefox will display it differently, Safari will display it differently, right? It's just going to be confusing, and the developer will have to make 5 different type of codes. Like if it's a Safari, this is the code. If it is a Firefox, this is the code. Well, that's ridiculous, right? We don't want to do that. That's why we have come up with a standard. So I lose my place here. What are we? The standard, right? So we have the standards of this API. So our codes will always look the same. So the JavaScript can be written once and run everywhere, anywhere. That's the point of the standards, okay? The standards of the web APIs. So adding web APIs to the picture. Previously, so we've discussed this on the previous module, on this module here, okay? We created a picture of the JavaScript runtime. Let's do a review quickly. Requests execute on the stack using a single thread. Okay, remember there's only one thread, not multiple thread. One thread. One at a time. It means one at a time. If you keep asking me every 3 seconds, I'm not done with your first request, dude. Don't keep asking me. Stop bothering me. I'm working on this single thread. Like humans also single thread, you know. You think you can do multiple things at once? You cannot. That's not true. You're a single thread. You can only do one thing at a time. So does JavaScript. Okay? Because when you're doing something else, the thing you were doing before stops. You stop doing it, right? You change your action to do something else, but the things you are doing is actually stop. So a request, that's single thread. A request holds the thread until it is done executing all synchronous logic for that request. Okay, so for example, we tell JavaScript, make an omelette egg. So JavaScript is going to start cracking the egg, preparing the bowl, cracking the egg into the bowl, preparing the frying pan, and then scrambling the egg, put some butter or oil in it. That's one whole synchronous logic. If you tell JavaScript, get me an iced tea right now, it will ignore you. Boo! Your iced tea is in the queue. Iced tea is in the queue. I'm going to remember I'm going to make an iced tea, but not right now. Sorry, dude. I'm making an omelette, right? So iced tea is in the queue. JavaScript is going to finish making the omelette, frying it. After 10 minutes, the egg is served on a plate and served on for you to eat, and then JavaScript is going to get you your iced tea. So it's done. All the synchronous should be done, right? And then the next one is the new request. The iced tea will be queued, and then you're gonna actually make the iced tea when the omelette is done. Got it? So don't keep asking JavaScript to do everything at once, right? So the event loop moves to the next queued request into the stack when it becomes available. So my JavaScript says, I only have 2 hands, dude. I'm making omelette. Stop asking me other stuff, okay? So omelette is done. Okay, I have 2 hands. I'm gonna make you your iced tea now, all right? So only when my hands becomes available, says JavaScript. Okay, stop bugging me. Okay, we're now adding web APIs into our picture of JavaScript. These extend the core JavaScript language. They surface interfaces, or they bring interfaces. Surface, what does that mean, right? They so fancy. I mean, the language, they want to be fancy. They bring interfaces that perform much of the work that is critical to the user experience. This is your user experience, right? This is your user experience. Things that run in the background, in the engine, you don't see it. You don't have an experience. It's doing its thing behind your back. Behind your back. So you don't see what's going on. So, but a user experience is what you experience. You see, oh, it's highlighting stuff. Interesting. Oh, you can do this and then you can highlight it. Interesting. So that's your user experience, okay? So the web APIs brings user experience to the modern web. Like, this is cool, right? If you go maps, this is a lot of work here. See, it knows where my son is. Oh, I'm tracking him. Anyways, I know where he's going. I know where he's going. Well, what is that? Right? And all these maps, and then you can switch to satellite, whatever. This is all JavaScript magic, dude. So if you double click, whoa, look at that, right? Anyways, all of this cool stuff, close that and close everything here, is the user experience of the modern web, such as Google Maps, okay? For example, browser APIs can do what? Browser APIs. This is browser APIs, right? It knows where we are. It knows where I am, right? Right? It knows where I am in the world. Look at that. Boom. That's pretty cool, right? I'm just amazed with Google Maps. Anyways, interacts with the structure of the current page rendered in the browser. So web API can do that, can interact with the structure of the current page and then perform async request to the server without leaving the current page, right? So for example, say I have somebody, you're messaging me, right? It's going to be 5. I didn't leave the the browser. I didn't have to refresh it. 6, 7, 8, 9, right? That's all APIs and fetching it. What are we? Okay, so that's I hope I'm not all over the place. I'm just gonna want to make sure you understand what we're talking about here. Web APIs, okay. It can interact with the structure of the current page rendered in the browser, right? Perform async request to the server without leaving the current page, fetch API. Interact with audio, video, and graphics, we know about that. Interact with device features such as geolocation like Google Maps, device orientation. If you're on a phone and you're using Google Chrome and you flip your phone to landscape or to portrait, it knows how to change the structure of the whole content, right? And then client-side data storage. So most of the time, these APIs that add new requests to the queue. So we have a note here. So third-party APIs and JavaScript libraries that abstract or extend browser capabilities. So these play an important role in how JavaScript is used in the wild. For our purpose, in the context of Salesforce, this is what we're learning. We cover our JavaScript framework. What is it called? The Lightning Component Framework. So specifically, when talking about JavaScript on the Lightning platform, this module addresses the Lightning Web Component Development Model, libraries, right? Meaning, we can use a whole bunch of libraries that we didn't have to write, right? The Salesforce developers or architects made it for us. And for example, they have a library, we can just reference and we can just use that, like a gazillion lines of codes of JavaScript that they already wrote for us to just use. Okay, that's what it basically means. So moving on, take an example. So you have a list of nodes on a web page. This is a web page. Maybe this is the list, right? You will fill out some fields on the form. Click on a button to save the data, and a new item is added to the list. Maybe a to-do list, right? We're gonna do that exactly later on with a JS bin, like here, I think, or somewhere there. We're gonna play with that. What are we here? Click on a button to save the data, and a new list item is added to the list. For fun, let's say you also you will cache this new record locally to speed up the future requests involving that record. So what happens on this particular example? The simple use case would interact with the following browser APIs. Fetch API to save the record when there's a button to save the record, right? Like when we save at the bottom, is there a quiz? Should be like when we save this, right? It saved the record and it knows we've done the quiz. So if I go back to another module like this module, I can't see the quiz anymore because we've done it. See, it knows when we save the button, when we click on here, it's saved back to the Salesforce database that we've done the quiz. There's the button, right? So DOM API to add new item to an HTML list or to modify it. So as soon as I click on here, or when I click on here, I'm just going to randomly, we're not going to do the quiz, right? So still grayed out and, oh, it's green. Now we can submit the quiz. This JavaScript, right? So it can modify your current content. Where were we? Client data storage to cache the data locally in your browser, not safe yet to the server. So let's stop here I'm gonna separate the video for the DOM, the document object model. So I'll see you on the next video. I hope you enjoyed. I do take my time to explain it. I want to make sure you understand what we're talking about. So this is the foundation. Bada bing, bada boom. Hit that subscribe button and explore new trailhead grounds and learn to implement the most useful and popular apps on the Salesforce App Exchange. And do yourself a favor, like this video, and you'll be surprised on how much more you understand when watching this same video after liking it. Don't take my word. Watch this one more time after you like the video and see it for yourself. Bada bing, bada boom.